Let's talk about velocities. In 2.1, we went over some velocity problems. I just want to remind you the average velocity equals to the displacement over time, and make sure you understand position function. So to compute the velocity, now we define the velocity equals to the limit of f of a plus h minus f of a over h as h approaches 0. So let's take a look at the example. This example, we did it in 2.1. Hopefully you still remember this example. Suppose that a ball is dropped from the upper observation deck of the CN Tower, 450 meters above the ground. The question is, what is the velocity of the ball after 5 seconds? So first of all, the position function s, which is f of t, is 4.9 t squared. Hopefully you still remember that. So we want to find the velocity function. So we want to find v of t. So the v of t is defined as the limit over h. In this case, the function is going to be 4.9 t plus h squared minus 4.9 t squared. So pretty much I just plug in the equation, the function. Now let's take the limit. So we have to do some algebra work. Pretty much we just FOIL. So we have t squared minus 2th, t squared plus 2th plus h squared minus t squared over h. So we do some canceling. We ended up with the limit h goes to 0, 4.9, 2th plus h squared over h. So if you factor out this h, we can definitely cancel with the bottom h. So this is what I'm going to do. Now, we ended up with the limit h goes to 0, 4.9, 2t plus h. And when you plug 0 in for h, we ended up with 9.8 times t. And this is our velocity function, v of t. Now, for part A, they're asking you what is the velocity of the ball after 5 seconds. So pretty much they're asking you for v of 5. So all we have to do is plug it in the equation. So 9.8 times 5. And if you do the calculation, we ended up with 49 meters per second. For part B, they ask you how fast is the ball traveling when it hits the ground. So what do they mean by that? The observation deck is 450 meters above the ground. Okay, so keep that in mind. So the ball will hit the ground at the time t when s of t equals to 450. That is, you plug it in, because we know s of t is 4.9 t squared equals to 450. So our job is to look for t. So t squared is going to be 450 divided by 4.9. And I'm going to take the square root. on both sides. Okay, so notice that every time we take the square root, we have plus and minus, but this is t, so we only take the positive values. All right, I'm going to keep it that way and plug it in because I don't want to use approximation. So I'm going to have to find the velocity of the ball as it hits the ground. So we have v of square root of 450 over 4.9. And then finally, I can use the calculator for it. So we have 9.8 multiplied by 450, square root of 450 divided by 4.9. So it turned out to be around 94 meter per second.